put it under a water bath. So now, after I've inserted my mixture, I put the lid back on. Okay. Hello Rebate. Today we're going to discuss about the physical and chemical properties of matter. But before that, we have to define what a property is. A property is a set of characteristics of a matter. Now, we can classify properties into two, physical properties and chemical properties. Physical properties are those that can be observed without changing the composition of the matter. There are two types of physical properties, intensive and extensive. The intensives are those that are independent of the amount of sample we take. So they are the same for a particular matter regardless of the amount of sample. For example, the melting point, the boiling point, the conductivity, the malleability, and etc.
Yes, on the other hand, we have extensive properties. Extensive properties are properties that are dependent on the amount of the sample. Examples can be volume, length, and mass.
Yes, the other is the chemical properties. They are highly interrelated to chemical reactions. They involve a reactant being changed into a product. So we have to change the composition of the matter in this case. Example is rusting, burning, etc.
So, Radit, what do you have here?
Today, I'm going to demonstrate one of the methods of separating a mixture, which is simple distillation.
What is simple distillation?
Simple distillation is a physical method in which you separate a mixture of liquids by using their considerable boiling point differences. So, now let's look at the theory behind simple distillation. Now, when we have a mixture of liquids to be separated, as the temperature rises on that mixture, the more volatile liquid will evaporate first, and it will pass through a condenser tube such as this one, and the cool water coming through it will condense it and turn it back into its original form, which is a liquid. So we will have a liquid at the end of the tube. Now let me introduce you to some of the instruments we use for simple distillation. I have here a stand to hold my instruments. Then I have here a round bottom flask, which is made up of Pyrex glass. And this type of glass is heat resistant, so it won't be damaged by the heat it receives. Now, I have here an adjuster so that it can be connected to the condenser. And I have a source of heat, which is the Bunsen burner. Now, the condenser, what we use it for is that, if you take a good look, it has two tubes, the inner tube and the outer tube.
Yes.
The inner tube is through which, when the more volatile liquid evaporates first, the vapor will pass through the inner tube.
Yes.
The outer tube is used so that the cold water comes through here and it will cool down the vapor coming and it will condense it so that at the end of the condenser, we will have a liquid gathered on our conical flask.
Yes.
So let me show you what I just said using a practical example. Okay, so I'm going to form a mixture. Now I'm going to take 30 milliliter of ethanol. Okay. So okay, that's about enough. I'm going to add it to my beaker. Yes. And I'm also going to take 30 milliliter of water. So we're making the mixture to be separated. Okay. So this is about enough. Okay. So I'm going to put my mixture into my round bottom flask, but I'm avoiding direct heat contact. So I have here a water bath so that it can heat it indirectly. Now I'm going to take this out. I have a thermometer for later so I can identify their boiling points. And I'm going to put in some boiling chips.
What's the use of boiling chips, ready?
So that the water doesn't spin out of control while boiling. I'm going to add some boiling chips into the round bottom flask. Then I'm going to transfer my mixture, and I'm going to use a funnel for this. So I'll insert the funnel through the adjuster. Then I'll slowly add the mixture. To put it under a water bath. So now, after I've inserted my mixture, I put the lid back on. Okay. So I need to have a source of heat, which is what the Bunsen burner is for. So now it's on. Then, as I told you earlier, when the more volatile liquid starts to evaporate, it needs a source of water so that it can cool it and condense it into turning back into liquid. So I'll turn the knob on so that now I have a water supply. Now it's moving through, it's circulating, as you can see. So now the distillation process has started. Let's wait.
I'm seeing a change here. That's amazing.
Yes, Gabriel. The liquid is slowly dripping and gathering into my conical flask. So let's see the change. Let me check my thermometer. Well, the reading is around 72 degrees Celsius. So from our generalization, we know that water boils at a boiling point of around 100 degrees Celsius, right?
That's correct.
So we can assume that this liquid gathering in the conical flask is not water, but rather the other constituent of the mixture, which is ethanol. So here I have succeeded in separating the mixture. I have the ethanol separated in my conical flask and have the separated water alone here in my round bottom flask.
Yes.
So what is your generalization from the experiment that we just did?
Yes.
So Kebra, what is your generalization from the experiment that we just did?
Yes, my generalization is that distillation can be used to separate mixtures of liquids depending on their boiling point differences.
Very well. So now let's move on to our next experiment.
Yes.
So Kebra, what experiment are you going to perform?
I'm going to show you one of the methods of purification of compounds, that is recrystallization.
What is recrystallization?
Recrystallization is the process by which we can purify solids.
Okay, show me.
So, the main principle behind recrystallization is that the amount of solid that can be dissolved in a solvent can be increased by increasing temperature. That is why we have Bunsen burner here and a water bath. To demonstrate what I just said, I have here prepared benzoic acid. As you can see, it's in the solid form and it's also in pure benzoic acid. So I'm going to add this to my flask here. Let me take some. That much is enough. And I'm also going to add water. Then I'm going to put it into my water bath. And I'm going to keep on stirring until it's fully dissolved. And if it's needed, I can also add water again.
Okay.
It's going to take some time, but it will be. Let me add some water. Then I'll keep on stirring. As I said before, it will take time, but it will dissolve.
Are we supposed to add water now?
Not now. We will wait a little. A little more. We will wait a little. It's dissolving little by little.
Right.
You can see, right?
I can see. Almost fully dissolved.
Yes, almost. As I said before, as the temperature increases, the amount of solute that dissolves will increase too.
That's why it's dissolving more and more?
Yes. Now that it has fully dissolved, I'm going to pour it into my beaker here. I'm going to pour this to my beaker here. In fact, at this stage we were supposed to filter it, but I'll just pour it into my beaker here. Let's wait and see what happens.
Okay. What is that white substance forming?
It's not forming, but it's the substance that was not dissolved from the earlier experiment. Let me add a few drops of water.
I can see some things forming.
Yes.
What are those?
I think they're solids of benzoic acid.
Okay.
There's a change, as you can see.
Yes.
It's not a pure solution now. Let me stir it slowly, very slowly.
Okay.
You can see the change.
Yes, some crystals are in the solution.
Yes, crystals.
What are they?
They are benzoic acid crystals. That's what we were expecting.
Okay. Very amazing.
Yes.
The solution is changing to crystals.
The crystals are forming.
Yes. So will all the solution change into the crystals?
Yes.
Okay.
That is what recrystallization is.
Very impressive. The solution has totally changed to crystals. Yes.
Can you please bring me the filter paper, please?
Sure.
Here, thank you. Now I'm going to use this filter paper to filter this solution, and I'm going to get a pure benzoic acid from the water solvent. Can you hold this for me, please? Sure. I will pour it to the filter paper slowly. So as you can see, Redate, we have got pure benzoic acid here.
Yeah, very impressive.
Yes, on the filter paper we have pure benzoic acid.
What's this difference from the earlier benzoic acid?
This is purified, and this, what I had first, was not pure, it was impure. And now it's pure. Yes. So what's your generalization from this experiment?
Well, recrystallization is one method of purifying solid compounds.
Yes, that's very correct.
Yes, so let's generalize the experiments we performed today, shall we? First, we saw the physical and chemical properties of matter. We defined property as a set of characteristics. Then we showed some ways of separating a mixture. The first was a physical method of separating liquid mixtures, which was simple distillation. Then we saw another method of purifying solid compounds, which was recrystallization. So that is it for today.
Yes, thank you.
Thank you, Hero.